Okay, so this is what I did in the exam. For question number 2, if you did not show full correct solution, I did not give you any credit. Because it says solve, first you have to find the equation. And then you're going to match your answer with one of the question given to you, one of the choices given to you. So if you did half work and then pick the correct choice, it's 0, because you did not show full work. You must show all the correct work. The most people get wrong the first page is question number 3. Because you did not subtract -1, you added -1. But it clearly says the first one minus the second one. Common mistake. Which one is it? Question number 3. Most people got it wrong because of that. You did not subtract. When you subtract a negative, you are adding. So the two numbers cancel out. In the second page, if you did the most common mistake for E is 2 to the negative power, 2 to the -2, meaning if you give us -4. 2 to the -4 is not -4. So 2 to the -2 is not -4. So 2 to the -2 definitely is not -4. That's why I told you many times, don't apply the negative power until you convert them into positive. Because if you do convert them into positive, you will see that this will come down and it will become 2 squared, which is 4 on the denominator, not -4 on the numerator. So it was common mistake. 5A, many of you did not get correct. So let me show you 5A. I did not make that question, okay? It was from the final exam. In the final exam, it was given. Cube root of 54, x to the 4, cube root of 3, x to the 7. So we multiply or we put together the numbers and we put together the variables. Wait, what happened? How did I? This is so weird. I know, I don't know what happens. Okay, let me close it and reopen. Same problem? Okay. So cube root of 54 times 3 and cube root of x to the 7, sorry, x to the 4 and x to the 7. Now, if you try to multiply 54 and 3, you're going to get a big number. So why you are wasting your time? Don't multiply big numbers, just split them. What two numbers comes in your mind when you see 54? You see 27 and 2? No problem. 2 and 27.
27 would be 9 times 3 or 3 times 3 times 3.
So 27 is already 3, 3, 3. If you don't see 27, no problem. You can see 9 and 6. Why do the same thing? 54 is 9 and 6, but he split them more. 3, 3, and 3, 2. It doesn't matter which way you do, you still have 3 3s, and then you have 2 here, and if you split it 3, it's 3 and 1. The 1 doesn't count. It's always there everywhere. So that means we have 3, 3, and we have 2 and 3, which is 6. So cube root of 3, 3, and cube root of 6. We got 6 from these two. You cannot forget about the times 3. So 3, 3 cancel out. We get 3 extra. So it's 3 free. And cube root of not 2, it's 6. 20 add, we get 11 over 3. 3 goes to 11 how many times? 3 times. 3 times 3 is 9. How many remain there? 2. That means we have x with the 3. And inside the house, x with the 2. So what's the answer? 3x cubed outside. And inside the house, it's 6 and x squared. This should have been easy for you guys. Even if you could not do anything with the numbers, at least you could simplify the variable. But many of you did not do that. Okay. Next, I to the 40, I to the 43, I to the 46, and I to the 49. I told you, you didn't have to do any math. Just remember the rules. If it's even, divide by 4. If it's divisible by 4, the answer is 1. If it's not divisible by 4, the answer is -1. Can you divide 40 by 4? Yes. So the answer here is 1. Now 43 is odd, so we're going to skip. We are going to 46. Can you divide 46 by 4? We cannot. So what's the answer here? -1. You don't need any math. Just put division, try to divide by 4 and see what do you get. Now for odd, we have 2 scenarios. We split them into 2 pieces. One is what? 42 and single I. Now, can you divide 42 by 4? No. So what's the answer here? -1 I, which gives us -I. Now 49, I to the what? 48 and single. Can we divide 48 by 4? Yes. So this is 1 times I. So we get simple I. 1 times I. That means the first term is 1, second term is -I, third term is -1, fourth one is +I. What's the answer? 1, 1, I cancel out. The answer is 0. You don't have to memorize anything if you only can remember divisible by 4 is 1, not divisible by 4 is -1. That's all you have to know. Many of you did. What you did was you added all the powers and you thought that was the answer. Wrong. To rationalize domain. Domain means for the first one, denominator cannot be 0. And for the second one, you have to see what gives us the inside of the radical positive. So you check each point once you solve for x. check them using the number line, and then whatever makes sense, that's your answer. Rationalizing the denominator, you need conjugate. Conjugate means what? Same two things you have, you keep the same two terms, just the middle sign is different. Many of you did not remember that. You multiply top and bottom by the same denominator. Wrong. Every time you see I square, what is I square? How much is I square? -1. So anytime you see I square, you must convert it into -1 and the term will change its sign. Solving radical equation, you must solve it in correct way. You cannot simply take the choices and substitute and see which one makes sense. It's not called solving, it's called checking. If you just check your answer, you get 0. Because you did not say check, it's a solve. Solve for x. So you must do it correctly. Otherwise, it's 0. And all the exponent rules, it was shocking. What is 0 to the -3? What is 0 to the 0? Zero is a very picky. Remember I said the story, he's the youngest child. He's very picky. It doesn't take everything. It takes only the positive number. So only 0 with something positive gives us 0. Otherwise, everything else gives us something that doesn't exist. What is 1 to the anything? Positive, negative, fraction, decimal, it doesn't matter. 1 to the anything is 1. Then how come many of you gave me the answer for this one is -1/4? Why? Okay. And the rest of the rules? What is x to the -1? 1 over x. So if you give me it's -x, what do you think I should feel? Or how do you think I should feel? 1 over -x is -x. Okay? I really had hard time grading the exam because I was expected so much, because I already told you before the exam what will be in the exam. So I was expecting, oh, you guys studied so hard, you know everything, and then the exam will be real easy for me to grade. But in reality, it was the opposite. So in the next exam, please don't give up in the middle of the exam and study way harder than how much you studied for this exam. Our next exam will be end of this month. So either it's on October 29 or it's November 1st, one of these 2 days. And it will be based on chapter 11. Chapter 11 talks about all about quadratic. Quadratic means the highest degree of the polynomial is 2. Okay. Any question before we start the lecture? Any complaint? After class? Here's a complaint for after class. It's a joke. Any other complaint?
Okay, guys, but don't worry about me.
Make the test easier and have more multiple choice, please.
Multiple choice doesn't have any partial credit. Are you agree with that? Oh, we're not allowed to have any partial. Next exam has 2 portions. The first portion doesn't have calculator. The second portion you're allowed to use calculator. Harder, definitely.
But we're gonna have the same amount of time.
But we'll split into 2 pieces. So from 12:30 to let's say 1:30, is the first part. And actually, in the second part, it's only 3 questions of problem. So 20 minutes for the second part and just the time for the first part.
This stuff out on this test will be on the next one.
Only chapter 11. But the final exam is cumulative. Everything you're studying here will be based on the final exam. Final is based on that. 30%.
So we're gonna have less time than your first class for the same exam.
Not less time. Like we are gonna divide the time into 2 slots. In the first slot, it's non-multiple, non-calculated portion. So you're gonna do everything without using calculator. And it's a big portion. So 20 minutes. So our class is 1 hour 40 minutes. So 1 hour 20 minutes on the first part and 20 minutes on the second part. In the actual final exam, there are 30 questions, 2 hours. 1 hour, 30 minutes in the non-calculated portion and 30 minutes in the calculated portion. Any other question? No? Okay, let's think about something logically. What number square is 4? See, we all can see easily it's 2. But it's not only 2, right? We also have a -2. But did you see all of you said, most of you said it's 2, because you can see it's 2. But when you think logically, it's not only 2, it's also -2 times -2 gives us +4. So for solving quadratic equation, if you try to just solve it using algebraic operation, you may forget that you have the solution. So you should not forget. When you forget, you're losing one solution. It means you're losing half of what you're supposed to get. So either you use your logic to solve quadratic equation, or if you don't remember your logic, then you must remember anytime you solve a quadratic equation, if the right side is not 0, you always have 2 solutions. For example, if I try to solve this using algebraically, we add 4, so x squared is 4. And then what do you do to get the epsilon? Not divide, you take the square root. So square cancel out. We get 2, but it's not done. It's plus and -2. So see, when we are trying to solve this equation, x squared equals 4, that means x is plus -2. This will be true for any case or every case except for one. X squared equals any number, you're supposed to get 2 solutions, except in one case when x squared is 0. If you have x squared equals 0, what is your x? Is it plus minus 0? Plus minus 0 doesn't make sense, right? Because plus 0 minus 0 is 0. So only when you're solving x squared equals 0, you get one solution. But except for that, every other time when you solve for x, you get how many solutions? So if x squared is 9, what is your x? Plus minus 3. So it's plus 3, also it's -3. Because -3 square is 9, also +3 square is 9. So why I'm showing you this? Because when you solve any quadratic, at the end, you bump into this situation where you're going to take the square root. When the square root, you definitely should not forget the plus minus sign. Now, how about this question? How are you going to solve this question? Think about logically. What number -1, when you square that, you get 1? One of them is 2, definitely. X is 2. Oh, man. How about, let me insert a page here. Yeah. X minus 1. X minus 1 square is 1. See, Stephanie, definitely. So one of them, when x is 2, we have 2 minus 1 squared, which is 1 squared, which is 1. So yeah, 2 minus 1 squared is 1. But is it the only number? When you subtract 1 from that and square the result, it becomes 1. Can you think of any other number, Julia? 0. When x is 0, we have 0 minus 1 squared, which is negative 1 squared. It turns into 1. You see, we get two solutions. One is 2, one is 0. So usually when we solve any quadratic, we get two solutions. So that's why we have plus minus choices. So if you take the square root, we have x minus 1 equals what? Only 1 plus minus 1. Anytime you take the square root of a variable, see your left side is a variable, which is the square root. So if you take the square root of a variable, the right side is supposed to get plus minus 1. If it's 0, plus minus sign doesn't matter. Except for 0, if you have any other number, you must put plus minus. Why? Because we are going to get two solutions that makes sense. But what does it mean? X minus 1 is plus minus 1.
Like there will be 2.
So what is one of them?
X minus 1 equals to 1. And x minus 1 equals to
Great. This is what it means, plus minus 1. One of the right side is 1. And again, another time the right side is negative 1. So x minus 1 is 1 or it's negative 1. And then you solve for x from both. So what do?
we'll need 1.
We add 1. So what do we get from the first one? X equals 2. And x equals 2. You see? Algebraically, when you solve, we get two solutions. If you think logically, it makes sense. There are two numbers. When you minus 1 from them, and then square the result, then says 1.
I also did the mathematics. I opted the parentheses. I divided 2x minus 1. And I got this answer. So it's bad math.
This is wrong.
Wrong.
So you said you did this. X minus 1 equals 1?
No, x minus 1 multiplied x minus 1,
Mm-hmm.
and then equals to 1. Then solve this.
And then what did you do?
And got, then multiplied the parentheses and got x squared minus 2x minus 1
Plus 1.
equals to 1.
Plus 1 equals
Plus
1.
1 and equals to 1.
Then this is
And then
correct. If you do this way, if you FOIL them out, it's correct. But FOILing doesn't always help. Because there are two possibilities. When you replace x with any of those, you get the same result. When x is 2, we get 2 minus 1 square is 1, and 1 square is 1. So when x is 2, the right side is 1. It makes sense. Same thing when x is 0, we have 0 minus 1 square, which is negative 1 square, which is 1. So you get the same thing, right side is 1. So this equation satisfied for two answers.
So they can use that.
We thought them logically, and then we solved them algebraically. Algebraically, when you take the square root of any variable, anytime it is the square of a variable, the right side of the equal sign and the other side of the equal sign is supposed to have plus minus sign. Why?
Oh, okay.
Because we have two choices. Anytime we solve, we have two choices.
Oh.
Except for the zero case.
How'd you get the
Second.
like both those answers? Like how'd you get 0? I understand.
Algebraically solve them.
So you recommend that if we have the number squared, to just find the square root of both sides? What if it wants to cube? Do you find the third?
Cube root. But in this section, it's usually square.
So the,
Quadratic.
the final answer is x equals 2, x equals 0, or is it the x plus minus 1? Like, what would the final answer be?
But this is not the final answer. Final answer is when x is alone. Is it x alone here?
No.
So it cannot be final answer.
Right.
So why is x alone?
With x equals 2 and x equals 0.
That's the final answer. Stephanie, more question? Any other question? So bottom line, anytime it is the square root of a variable, the other side of the equal sign must get plus minus sign. And then from there you solve for x.
So for that, you always put the plus. Like,
Always
sign.
plus minus sign. Whenever you take any square roots.
So it won't be positive or negative equal.
Mhm.
When you do
So we take the first equation as a positive and the second equation as a negative. And then solve them individually. So that is our goal. That's how we like quadratic. Because you don't have to do hard math. You can take the square root and then we can solve each equation separately. Now, we all know. Huh? Okay.
Are we going to do,
How do you write it?
quadratic formula?
Quadratic formula is useful for smaller number. What if I give you a big number? Then you get square root of 4ac, which is a big number, and then you get stuck.
Yeah.
So depending on what number you have, you use different methods to solve.
Yeah.
But anytime you're given the square, don't FOIL them out because FOILing out makes you like harder. Just apply the square root, and from there you do the rest. So quadratic means the highest degree is 2, and we have many ways of solving it. Here I have only 4 methods. One is factoring, one is complete the square, then you can use quadratic formula, or you can simply graph it. If you graph it, it has to be graph, not a sketch, it's actual graph, which is harder to do. That's a graphic method is a bad one. Easy one is factoring, if it's factorable. If it's not factorable, then you have to buy the one of them. The first one, factoring, we already used it many times. Even in the exam, we used it. X squared, when you solve the radical equation, at the end, you got x squared. Do you remember in the exam, the solving radical equation? It was like at the end, x squared plus 6x minus 16 equals 0. Do you remember in your exam? At the end, in the radical equation, the last page, when you solve the radical equation, this is what you got, a quadratic equation. So what did you do? If you did it correctly, we factored. Yeah. What are the two factors we got? Positive 8 and negative 2. So in factoring, we find two numbers multiplied to the constant, combined to the middle term. Chris.
Like fraction. Still like that. Because I know it's meant to be like one number plus another number equals that, and then one times another. Like I still don't really get it.
Which one?
So
I'm showing you how to use factoring method to solve everything. So if you have a quadratic in this format, not factored form, this format, then if it's factorable, our life is easy. You just factor and then solve. That's not always be factorable. So what did you ask? Are you asking me about the exam question
No,
or this one?
You're gonna need to watch it.
No problem. Maybe how about the other question. The factoring method. I'm discussing the factoring method here. How to use factoring method? We have a quadratic. We factor if it's possible. So it is possible we factored, and then what do? We set each factor equals 0, right? So we get x equals a negative number and x equals a positive number. So this is called factoring method. You factor, you set each factor equals 0, and then you solve for x. But our life is not easy all the time, right? Sometimes we bump into some question that is not factorable. When a quadratic is not factorable, we go to complete the square method, or we go to quadratic formula method. So here I'm going to show you complete the square method. Complete the square method says when we have a quadratic, our goal is to write in this format: x plus or minus doesn't matter, something square, which becomes this. Okay, this is our goal. We have this version, but we want to rewrite in this version. What is that something? Well, mathematicians figure out that that something is the middle term, half of the middle term. So we can complete this into square if we just put x from here and half of the middle term here. They are the equivalent expression. Now let's do something in details. Let's say this is positive 8. Our goal is to solve for x. And we are going to use complete the square method. Before we even start the complete the square method, do you notice something here? What do you notice?
The 2 next to the x,
All the coefficients are even.
and they are divided.
So we can divide all of them by 2. And in order to complete the square, we have to get rid of the number in front of x squared. That is a requirement. We must. Sometimes we can divide, sometimes we cannot. When you cannot, then you get a fraction. So we have x squared minus 4x equals 4. Okay? Now, let me show you just a shortcut, okay? The shortcut says,
Change the sign.
yes, with the positive 8. Because if it's negative, it's factorable. But I want to show you something that is not factorable.
-4 on both sides.
We can do that, but it will not be helpful. If you do -4, can you factor these two numbers multiplied to -4 combined to -4? Is it factorable? Since we are not going to factor, then there is no point of bringing the constants. In order to complete the square, we only need 2 terms. The terms that have x in them. The constant is useless, so we kick it out. Kick it out. Here it's already kicked out. Okay, we don't need this 4 on the right side. We are going to complete the square from here. So what do you want to see? The shortcut method or the details? Shortcut. Shortcut is better for you.
Sure, it's the same time.
Same time, plus it doesn't confuse you. You just have to remember 2 rules. From here, we get a perfect square. And we have our 4 same. These 2 doesn't go inside, something else goes inside. What goes inside?
X minus 2.
X from the first term and half of the middle coefficient. Only the coefficients. So from x squared, it's x. From the second term, it's only half of that amount, which is -2. It doesn't matter what do you have. It's always half of the middle term. Always.
What if it's like not?
Half of 9, which is 9/2.
Oh.
Whatever you have, it's always that number divided by 2. Here it's 4 divided by 4 divided by 2 gives us only 2. Go ahead, Cole.
How come it's not -2 then?
We're not taking x because we want x only once.
But yeah, like how do you get rid?
I did not get rid of it. I just used a trick. The trick says from the 2 term, if you write a perfect square, if you use the trick, take x from the first term and take half of the middle coefficient.
Yeah, because if you take x minus 2 multiply it by x minus 2 is going to be x squared minus 4x.
And then something extra.
Yeah.
That extra we are going to add here. So what will be that extra thing?
4.
This thing square, which is 4. How'd you get 4? Okay, let me use her technique, the way she figured out. Okay, if you do, let me do it on the side. Our goal is to have x minus 2 whole thing square here. This is our goal. So we randomly wrote this, not randomly, we actually used the mathematician technique that told us it's half of the middle term square. X plus half of the middle term and then everything square. That's the rule. So from the first two, we had x and then half of the middle term, everything square. Now, if you expand this, look what we get. Let me change the color to something else. If we expand this, we get x minus 2 times x minus 2. That gives us x squared minus 4x plus 4. We already have x squared minus 4x, x squared minus 4x. But we have something extra here. This extra we did not use here, right? That means we have to use it on the other side. So this extra 4 goes here. But in general, that number is actually this number. Okay? So that's the rule. Whatever you add here, square that on the other side.
So if it's a fraction, we just do the same thing.
Fraction square. And you always add.
Do you want us to write the fraction parentheses square or write it out as it is? Like for example, 9/2, do we put
9/2 square.
front?
Which will become 81/4. So let me write down the rule here. This is, you will not understand half means, b/2. And this is always b/2 square. So you add b/2 inside the parentheses, but you add b/2 square on the other side of the parentheses. So the other side of the equal sign. This is the rule. Let me finish this. So at the end, we got x minus 2 square equals 4 plus 4, which is 8. And now we know how to solve this, right? Because we did it before with another example. How do you solve for x?
I have a question. I'm not understanding why you added 4. is when you do our M4, if you put it into the, like, 8 is, it cannot be negative and positive. And
What do you mean? I added 4 because this is the rule. Inside the parentheses, you add b over 2, and outside the parentheses, on the other side, you add b over 2 square. So inside we added -2, outside we added -2 square, which is 4. Solving comes later. The first part is making the equation correct. Okay, before even solving, let's do another example. Let's say we have x squared minus 6x equals 3. If we complete the square, what goes inside? X minus 3. And then on the other side, what do you have to add? Only 3?
9.
It's -3 square, which is 9. Let's say you have x squared minus 5x equals 7. X minus 5 over 2 because you're dividing 5 by 2. And what do you add on the other side? 25 over 4. So 5 over 2 square. So that's the rule. You add without the square inside, but you add with the square outside. But you have to add on the other side of the equal sign. Okay, one more. Chris, you gave up. Let's work with you. We have x squared minus 2x, let's say equals 5. Our goal is to complete the square here. So we are going to put something inside the square. Excellent. That means what do you have to add on the other side? With the 5? -1 square.
Is that the final?
Not final answer. This is how you complete the square. So this is the part where you completed the square. What is square? This thing. From a two term, we wrote a complete square term. Why? Because now you're going to solve. Solving this is easy. Why? We have to do what? Square root. And when you do the square root, no more square. It's simple x. So we get x minus 2 equals plus or minus square root of 8. We don't know what is square root of 8, right? Can you break it down?
Yeah.
What two numbers? 4 and 2. In other words, it's plus minus 2 square root of 2. But our x is not alone. So what do you do? So Chris, do you see here our x is not alone? So it's not solved yet. In this step, we took the square root, we simplified our radical, but our x is still not alone.
Is this in your pleasure?
I did have here and then I start because people didn't understand how they get this. So let me actually erase all this bunch here.
Same condition.
So now you know the rule, right? So let's start this question again from the beginning. What can we do inside and what can we put outside? Inside we have x minus 2, and outside with the 4, what do you have? -2 squared, which is 4. The same amount is square. In other words, we have x minus 2 squared is 4 plus 4, which is x minus 2 squared, 8. Great. So what is our last step to get the x alone? Am I confusing you guys?
Wait, are we still answering that question?
Yes.
You?
Check yourself. Check yourself. We have x minus 2 squared equals 8. Are we done?
No.
No.
Because our x is not alone.
Right.
So what is our next step?
Okay.
It is a square root. Once it is a square root, what happens? Plus minus square root of 8. Square root of 8 is not a perfect number, but we do have a perfect number inside. So we simplify this. But we still have the same problem. X minus 2 equals that. But our goal is to get the x alone. So what do you do?
Add two.
Add 2. Go ahead.
What? Like, there's no equation, right?
Mhm.
Does this, to me, like all honesty, this is very confusing. Like, you love math like the so we think like why can't you get why stuff that in the quadratic? I feel like that was
Why don't you do what?
I don't like
Because quadratic formula is another method. I'm showing you other methods.
it's like oh
It's a method. Sometimes complete the square is helpful. Sometimes quadratic formula is helpful. Sometimes factoring is helpful. Factor is always helpful if it's factorable. If it's not factorable, then you have two choices. This method or complete quadratic formula.
But you said quadratic formula is not good.
True. What happened to my plus 2? Why? So we have x equals this, but what does this mean?
1x equal to 2
2 square root of 2 plus 2, and the other one is negative 2. Ah, it's too small. Negative 2 square root of 2 plus 2. So you have two numbers that satisfy that condition. First one is usually confusing, but once you do the next one, it will be easier. Chris, go ahead.
Yeah, so all of that actually kind of makes sense. The only one that I don't get is where we went, so x minus 2 equals plus or minus our 8 or whatever it was, into the 2 and then 2, like that bit down.
We have x minus 2 equals plus minus 8 is plus minus divided by the square root of the variable. So you have two choices always. Now 8, do you know what is square root of 8?
It's either,
Without calculator, you don't know. It's not a perfect square number. But we can actually simplify that. Anytime you can simplify something, you must simplify. You can simplify because 8 is 4 times 2. Do you know what is square root of 4?
what,
Do you know what is square root of 2? Let's start again. So this is a simplified version of square root of 8.
okay.
final, do we have to write it separately or can we just do it first?
Unless there's multiple choice, so you're going to see them separately. But no, you don't have to write it down. I wrote it down to show you that plus minus means two answers. Okay, apply your confusion here for the next question. Or do you want to do another question together? Let's do one more together.
Same method?
Yeah. Details? I'll show you after class. Because I showed in my morning class after showing the shortcut, and then I was like, what's going on? What is this? What is that? I was like, okay, never mind. So I'll show you in person. Another example. Let's say we have, huh? X squared minus 6x equals 5. Yeah. X squared minus 6x equals 5. You may think it's factorable, but actually it's not factorable.
What?
You may think it's factorable, but actually it's not factorable. You choose computer square.
Oh, you want
Trust me, if you know computer square, you learn to be much easier when you work with a big number. Quadratic formula has a downside. It doesn't work with a big number.
does it not work or it just takes long?
You don't know how to solve it without using calculator. That's why it doesn't work. This is what it means. It doesn't work. Without calculator, you'll be hopeless. Tanhi, are you already done? Ah, Tanhi, are you already done? Run. One point square. After you have to divide everything by 2, but that's not the answer. We say it's actually it's always in. And then we need to get that number is always wonderful, but we need to process it. It's between that it's be the process.
Yeah.
No, what?
No, that plus minus only is but 7 and 2 was not part of it. The 14 is not breakable. That's not breakable. Therefore, 8 was breakable 4 times 3, 4 in the square root. 2 doesn't have a square root, 7 doesn't have a square root. So what's the point? It's not breakable.
Wait, that's it. Or just nice.
Yeah. We do not part of like separate.
Okay, yeah. Couple would be.
Got it? How about this side?
Oh. I just changed that number like halfway there. Yeah, pretty good. Yeah. So it's the final. Oh, like. Yeah. I bet you.
See, it's not too bad. Come with the square method. So we do x and half of 6, which is 3 square. And then we add the same thing, but with a square. So x minus 3 square is 5 plus 9. That gives us 14. X minus 3 square is 14. So to get the epsilon, square root. And when is the square root, the right side of the equal sign gets plus minus. So x minus 3 is plus minus square root of 14. And breaking down 14 doesn't help us because 14 doesn't have any perfect square in it. So 7 and 2 doesn't help us. Don't break it down. Keep it. We add the 3 at the end. So x is plus minus root 14 plus 3. If you want, you can write 3 plus minus square root of 14. Or you can write x is 3 plus 14 square root 14 and 3 minus square root of 14. All of them are correct. This, or this. Okay, now try this one. One more. Again, you may think it's factorable. Is it factorable? If something is factorable, you always use factoring method, okay? Don't use any other method because factoring might makes our life easier. But is it factorable?
Oh, nice.
Two numbers multiplied to constant combined to the middle term. Pre-calculus has two portions here. The first part is pre-calc, second part is calculus. From the calculus part, they took the derivative and then put it as the second part of the pre-calc. It doesn't matter. The first part is pre-calculus. So once you're done with the pre-calculus part, then the chapter 2 is calculus, derivative. But they have a new pre-calculus, 2001. 2001 is pure pre-calculus. It's up to you which one you want to take, 2001 or 2003. It's up to you. 2003 is mostly science for science student, I think, or the maths. Accounting. Accounting doesn't need derivative. So if you want, you can see it in 2001. And 2001 actually a combination of this class and pre-calculus. So you're going to learn log, everything from chapter 12. We're going to learn those, and then some trigonometry, and then pre-calculus. So it's a pure pre-calculus. Are you guys done? Almost, okay. Chris, sorry, Chris, not Chris, Angel. Yeah, they want 2003. Talk to your counselor and ask, like, is 2001 is sufficient for you? But so far for business major, it's always 2003 or 2009. But for you, it's 2003 because it's 1030. 2009 is for 1023 track. For 1030 track, it's 2003. Same book, same everything, same things. But the only difference is 2009 meets 4 days a week, and 2003 meets twice a week. That's the difference. 1 hour, 15 minutes each day. 2003 is normal, 140, 1 hour, 40 minutes. 2009 is 1 hour, 15 minutes every day, 4 days. 2001 is also same, twice a week. 2009 has more time. Same thing at 2003. They just need more time. So those are for 1023 students mostly, because 1023 they made 3 days a week, 1 hour 15 minutes per week, so per session. But 1030 we are meeting twice a week and 140 per session, right? 1 hour 40 minutes. So we are learning not same materials, actually different materials, but we are going towards the same calculus. But again, whatever you want to take, talk to your counselor, because they can tell you more in details which class is good for you, which pre-calculus. Probably development of the registration. Okay, now you guys are done. Gerald, what do you do first? Wonderful. We don't need this number. We kick it out. So we get x squared plus 8x is -9. Then why it's minus? What is your b? So b is 8 positive. So that number should be positive half of that amount. And now what you are adding on the other side? 16, which is this number square. So we have x plus 4 square, and how much is negative 9 positive 16? 7. Okay. So Chris, you always ask me, are you done? Are you done? Are you done? You tell me, are you done here?
I always ask.
I'm just joking.
No, because there's still some. That's like some-
Exactly. X is not alone. So what can we do next to get the x alone?
So to get rid of the brackets and the square, you do the
Square root. So one problem is solved, the square is no more there. But what do we have on the other side? Only square root of 7?
I took that. Maybe plus minus.
Plus
Called here?
minus. Plus minus.
Expression is called plus minus.
Because it's plus and minus together, so it's plus minus. So you have two of them. Are we done, Chris? We are still not done. What is left then?
So the 4 still left, but I
See?
factor the side or like the
Not factor.
So-
What sign you have between x and 4?
what's that?
What sign? How 4 is connected with x? With
What's the
addition,
point?
subtraction, multiplication, division, which one?
You'd subtract it to get to the other side. I just didn't know if we did that thing with like the.
You can do
square root
it
seven.
below or you can do it next to that, but you definitely cannot combine them, right?
No,
Because 7 is the square root, 4 doesn't. So x is plus minus square root of 7 minus 4. Now are we done? Yes. As long as the x is alone, we are done. But if you want, you can split that into 2 pieces. You don't have to, but if it makes your life easier to see what's going on, you can write positive square root of 7 minus 4 and positive square root of 7 plus 4. This is what plus minus means. You have, sorry, my bad. Minus square root of 7 minus 4 or plus square root of 7 minus 4. Now let me show you something based on Dua's question. Why we are learning this? Why can't we use quadratic formula everywhere? Well, let me show you one example. Why quadratic formula is not a good choice for everything. Let's say you have x squared minus 7x plus 49. Why do you have 7? Let's say 5.
so you do 49 to the other side first, so negative 49.
True, if you use quadratic, if you use complete the square method. But let me show you how to solve this using quadratic formula. Quadratic formula. So this is another method, okay? Remember there are 4 methods: graphing, quadratic formula, complete the square, and factoring. So factoring is possible only if it's factorable. Is it factorable? Definitely not. Graphing will be harder. We hate graphing. Now we already know how to solve this using complete the square, but now the last thing is how to solve anything with quadratic formula. So what is a quadratic formula? X equals
That's a lot. Square. U squared minus 4a over 2.
okay. That means you have to identify what is A, what is B, what is C. So number one problem with the quadratic formula is you must memorize the formula correctly.
So that's the formula right there,
Quadratic formula.
including like the 20 or that 2a.
Everything.
That's 2A under it?
2A. Okay, so if you do want to use the formula, problem number 1, you memorize it correctly. If you memorize it wrong, that's it. You're wasting your time.
Do we have to do it this way or?
Of course not. In math, you don't have to. You don't have to do something in one way.
We have to use this by the-
It's up to you. For example, if you use complete a square, you have to work with fraction. If you hate fraction, it's not good for you. So what is A? 1. What is B? And what is C? 49. So negative B means what? Negative, -5.
We got these numbers.
This is A, this is B, this is C. A, B, C. So plus minus -5 square minus 4 times 1 times 49. 2 times 1. So you have positive 5 plus minus 25 minus. So second problem, you have to do math manually. I give you only 2 numbers to work with, so it should be easier. But in your case, maybe it will be 3 digits by 3 digits. So second problem. But anyway, 136. 4 times 9 is 6. We get 3. 4 times 4 is 16, 17, 18, 19, 196. I chose an easy example. I should have picked a harder one. True. Here. How much is 25 minus 196? Now I'm not doing anything, I'm just doing the math portion. 171 over 2. Technically, we are done. I mean, not done. We are halfway. Now comes the third problem and the biggest problem. What is the square root of that one? This is definitely I, right? Just imagine a number. Now, what is square root of 171? See, Dua, what is square root of 171 without using calculator? You get stuck?
No. Is 13, the square of 13 is 169 and 14.
171 is not a perfect square number, true. But sometimes they give us a perfect square number here. So it does have a perfect square number sometimes. But see, this is the biggest problem. What is the square root of a big number?
How did
You have
we
no
get to
idea.
-171? Oh, it's subtracted.
24 minus 196.
So we will leave it like this.
Of course not. We have a negative, right? Anytime we have a negative, you must bring it outside. Since we have a negative, what is square root of any negative number? I, not nothing, it's I. So it's I square root of positive 171 over 2a. You can think this is an answer because you cannot simplify, not 2a, so it's 2. Because you cannot do anything else, you get stuck. But trust me, in the final exam, they ask some question where you bump into this problem. You have to take the square root of a number that does have a simplified version. But how do you know what that simplified version is without using calculator? No. So solving with computer square method will tell you what's the answer. So that's why computer square method is easier for bigger number. Plus, it's easier when we have b as even number. If it's b odd number, you have to work with fraction. So b even number and numbers are big, we don't care. We can use computer square method. Quadratic formula is easier when you have smaller numbers to work with. 49 is that small. So it bumps into problem.
We use something in the square to see if we got an analysis or
We're gonna get the same answer.
the same thing with the I.
But let's do it just to check. Complete the square method. We have x squared minus 5x equals negative 49, right? What goes inside?
X minus 5 over 2.
X minus 5 over 2. So what you're going to add?
25 over 4.
25 over 4. Because this is 5 over 2 square. So x minus 5 over 2 square. We need LCD, right? Here. So multiply top and bottom by 4. And we know 49 times 4 is 196. So negative 196 plus 25 over 4. We know this is negative 171 over 4. So x minus 5 over 2 square is negative 171 over 4. No problem. We take the square root. Ta-da-da-da. They cancel out. LCD, denominator.
I mean, 40 times.
So with negative 49, we added 25 over 4, which is 2 over 5 square, 5 over 2 square. Now we cannot combine them if they don't have the same denominator. So we want a 4 below negative 49.
Wait, what?
We cannot add them if we don't have the same denominator. So we want a 4 below the 49. Because we have a 4 here. We want the same 4 below
Wait,
negative
what's
49.
next to the negative 49?
4.
You have to multiply by 4
Because we want the 4 on the denominator. But we cannot put 4 on the denominator, we must put 4 on the numerator. Do you do your fraction? So we have x minus 5 over 2 is plus minus square root of 171 over square root of 4. What is square root of 4? 2. And what is negative inside the square root? I. But we still have this on the other side. Last thing we do is we add this amount. So x is 5 over 2 plus minus I square root of 171 over 2. Which is same as what we have on the left page. 5 plus minus I square root of 171 over 2. Oh, we don't have to do that. We can simply stop it. I'm showing you that you have the same results.
We should combine, just put them everything over 2 so they have the same
Same
result.
denominator. So we can solve the same question using many methods. Angel.
Disappear on final or next again?
In the final, they have two of these, if I'm not wrong. One will be, you can use quadratic formula, I think. And the other one, factorable, probably. I have to see and then I'll tell you later.
Hopefully it's not hard as like the. Like you add like multiple steps.
Guess what? They have what problem? And what problem you need to solve using one of these methods. Usually they are not factorable, the what problems. So now we know how to solve x using factoring method. All we need is a polynomial, a quadratic that is factorable. If it's not factorable, we have two choices. Complete your square or use quadratic formula. Quadratic formula has a downside. It doesn't work with a big number because you get stuck in the middle. But you can use complete the square anytime, no problem. If you are okay with fractions, you can use any of them. But if you don't like fraction, then don't use complete the square when b is not even number. Any question? So in the quadratic formula, we saw that inside we have b squared minus 4ac, right? That thing is a very special. Just by solving b squared minus 4ac, we can already tell how many solutions we are going to get. See here, we get two imaginary solutions. Previously, we got two real solutions. Without even solving anything, we can figure out how many solutions we are going to get just by observing that b squared minus 4ac. That's why it's very important. So our next topic is talking about discriminants. And before that, let me just remind you about our parabolas. We have two parabolas. When we have the leading coefficient positive, it's upward. When the leading coefficient is negative, it's downward. So this means positive, this means negative. Can I flip my page? Now discriminant. So since we solved already two questions, we've seen that, let's take a look at that. Here, the whole thing. This is the discriminant, whatever we have inside the radical. So this discriminant is a negative number here, right? How many solutions we got? Two of them. Are they real or imaginary? Imaginary, because I. So when the discriminant is negative, we get two imaginary solutions. On the other hand, did I do another one? I did not. Okay, no problem. Let's do it here. Let's say we have discriminant is positive. So we have x equals negative b plus minus square root of discriminant over 2a. So how many solutions we have now? We see the two solutions, right? Plus and minus. You don't see it. D means any number, okay? So we have negative b plus square root of d. D means discriminant, okay? Over 2a. And we have negative b minus square root of d over 2a. So how many solutions you see? Are they real or imaginary? Our discriminant is a positive number. So you have a positive number here. They're real. Because they're positive number. Anytime you have positive inside the radical, it's real. So when our discriminant is a positive number, we get two real solutions. That's the rule. Discriminant positive means we get two real solutions. Or if you're working with x-intercept, we get two x-intercepts. It means you're crossing the x-axis twice. And we already learned about negative. When our discriminant is negative, we have negative b plus minus negative d over 2a. That gives us negative b plus I square root of d over 2a and negative b minus I square root of d over 2a. So what do we have? Two imaginary solutions. And guess what? When your solution is imaginary, we cannot have any x-intercepts. So we have no x-intercept in this case. Because x-intercept must be real. Imaginary is not possible. Give me 2 more minutes. And then we have our last scenario. What if the discriminant is 0? Look at our solution. X is negative b plus minus square root of 0 over 2a. What is square root of 0? And what is plus minus 0 mean? Nothing, right? So what is our solution? How many solutions you have? One. Is it real or imaginary? Real. So when the discriminant is 0, exactly 0, we have only one real solution. And we have one x-intercept. So there are 3 scenarios we get by observing our discriminant. Either we get 2 x-intercepts, means 2 real solution, or we get no x-intercept, means 2 imaginary solution, or we get only 1 x-intercept, means 1 real solution. Why do we care? Because before you go, let me show you one final result question. I guess done. Something like this one. The discriminant of a quadratic equation is 19. What can you say about its equation, about its solution? This is a final result question. So discriminant is 19. That means our solution is x equals negative b plus minus square root of 19 over 2a. So how many solutions we have? 2. Definitely 2. Are they real or imaginary? Real. That means this is definitely not the choice. But we still have 4 more choices left. So never mind. Definitely not 1. Definitely not 1. So you have 2 choices left. Either it's too rational or too irrational. What is irrational?
It would be like someone's square root of 4, someone's square root of 2, something like that.
Irrational means we cannot simplify the radical. In other words, observe this. Do we know what is square root of 19?
No.
So what is our choice from here? What's the correct choice? To irrational solution. Because of this. Anytime we cannot simplify a radical, we call them irrational. So based on what discriminant is, we get either rational solution or irrational solution. Irrational means something with square root. Okay, thank you for today. Oh, Friday is the class. Did you know that? This week Friday is not class, so we are going to meet again next week Friday. Guys, next week Tuesday not class also. Next week Tuesday.
I want to verify. I copied it. Invite the right thing.
Maybe don't know what, because you see is here, right? To subtract C from both sides, which is summary.
Oh, that's what it means?
To subtract C
Subtracted?
from both
Oh,
sides.
I thought you said it's negative.
No, what you do is set this as this one. So you see, the whole thing equals 0, so you need to subtract C from both sides, because it's empty C. And then the left side is half of this, or the right side is half of this.
I thought you just said.
C, you subtract the C, so it comes into a negative number. But if it's already negative, it comes into a positive number.
Thank you.
Okay, so you.